have a look in the whiteboard. So first of all, let us define the problem. So like we have a 8255 IC. Okay, I think yeah, we don't have to declare. I mean, without drawing, I just writing the statement like port A. You cannot say make a refresh because I am writing on the whiteboard. I hope it should you should see it. But if it is not, then make it refresh. Abdul Hadi, make a refreshed on your system. Yeah, make a refresh, and if it doesn't clear. Okay, I am also giving a refresh. Sorry. Yeah, so yeah, now it is okay, I think. Okay. Okay, so so this is for A, B, C, and D. Face connected to 0, 1, 2, 3. Okay, wait. I'll repeat again. Just let me draw it and then. Okay, so look at here. We have two switch, S1 and S0. They are connected to port C, 6 number bit and 7 number bit. So 7 number bit is S1, for example, and 6 number bit is S0. Okay, and now and port A, four bit of port A, for example, 0 to 3, they are connected to 4 phases of stepper motor. This is our stepper motor. Okay, stepper motor. So we want to control the stepper motor like that. If S1, for example, S1 and S0, if it is 0, 0, motor is off. Is off. Motor is off. If it is 0, 1, then it moves single phase, one phase, single phase, wait, single phase, single phase, single phase, single phase um, uh, um, excited mode, single phase excited mode. Okay, shortly I am writing single phase excitation. 1, 0, 2 phase. Two phase excitation mode. Okay, two phase. And if it is 1, 1, it is half a step mode. As we discussed in the last class, one phase, two phase, and half a step mode. Half a step mode. Half a step excited mode or half a step mode. Anyway, half a step mode. Shortly. So now, so switches are connected to port C. Okay. So wait. Port C. In the last class, we said it is port C, PC. PC not and PC. Yeah, it's PC lower actually. So PC 1 and 0. It's like that. Okay. This is like that. Okay. So port C 0 pin. So that means it is okay. So yeah. So what is it now? The port A is connected to port A 0 to 3 pin is connected to 4-phase stepper motor, and port C, PC naught and PC1 2 bit, they are connected to two switches S0 and S1. Okay. So that means PC naught and PC1 they are connected to S0 and S1 switches. It is like that, and we have to control the operation of a stepper motor based on the switch condition. That means if it is 0 0, it is off. If it is 0 1, one phase excited mode. If it is 1 0, two phase excited mode. If it is 1 1, then half step mode. So that means alternately single phase, two phase, single phase, two phase. This is we discussed in the last class. Okay. Now it's about writing the code. So dot model port. And now port A, port B, as it is not given, we can use now, we can use the address if it is given, then we will use it. Or if it is to determine it, we should determine it. Okay. So for example, as the addresses are not given, so for example, port A addresses are 00H, like the lab one. Okay. Port B, PQU, 02H, let's see. Okay. Now it's about also we have to find the control word. What is the control word here? The control word. Okay. So the control word, it will be so this 0 bit is 0 bit 0 to 7, right? 8 bit. So 0 bit is for port C lower, and port C lower you can see it is an input it is connected to the switches, so it is input system. Okay, input. And port C, because port C lower 0 and 1 bit, they are part of port C 0 to 3, so it is input. And then port B unused, and this is mod 0, and then port C upper, don't care, port A as an output, and then this 2 bit is for mod 0 0, and this is 1. So it becomes 8 8 1 8 1 H, or 8 1 0 1 1 8 B. 1B 8BH. Okay, this is about control word. So control word is done. Now it's about to write finishing the program. So first of all, initialization. So move al comma control word. So 81 page, and then out control register AL. So control word is written in the control register. Now it's about is beginning of the program. Start. Because we have to make the loop again and again. Okay, start. The start. What actually, because as this is the, I mean, the control here is based on the switches. You know, switch condition. We have to read the switch first. So in AL comma switches. Switches are connected to port C. So port C in AL comma port C. And then now we have to check the condition. Is it 00 or 01 or 10 or 11, right? So this is about, you can see that, okay, so look at here. Port C, okay, port C, 8-bit port C, right? So we are only interested about these 2 bits, 0 and 1. So this is S1, this is S0. Okay. Other bits are don't care. So they can, so yeah. Okay, we can make them forcefully 0 because others are 0. So only changes about the, so others, how can we make it, we make it 0, others are 0. Just like AND, logical AND, right? AL comma 0 0 0 0 0 0 1 1. Okay, if we make the logical AND with this bit, so all the bits will must be 0 because AND operation, and this 2 bit 1 1. If we make logical AND with 1 1 here, so what are the situation here? It will be the, if it is 0 0, it will be remain 0 0. If it is 0 1 0, so on. It's binary. Okay, and now we'll check the condition. Compare AL comma, is it 0 0? I mean, if S1 and S0, if they are 0 0 and others are 0 0, so it becomes 0 0 H. If it is 0 0 H, it will go for off mode, right? Off, it will be off. So if jump equal, then off. It is a subprogram. Okay, if it is not, then compare AL comma. So now S1 and S0, if it is 0 1, if it is 0 1, then and others are 0 0, so it means 0 2, 0 2 H. If it is 0 2 H, jump equal. If it is equal, then go to single phase mode, single phase excited mode. If it is not, then compare AL comma. So S1 is not 1 0. It becomes, oh sorry, this one is 1 actually. This one is 1, not 0 2. L comma 0 to H. Now, if it is S1 and S0, they are, if S1 and S0, if it is 1 0, it is two phase mode, right? It works for two phase excited mode. So 1 0 and all others are 0. All others are 0. So it becomes 0 2. 0 to H, if it is equal, jump equal. If it is equal, then go to two phase mode. Okay, if it is not, then it will check for uh, compare AL comma 0 3H, because S1 and S2, if it is 1 1, all are other 0 MSB bit, so it will be 0 3H. Jump equal, it's a half a step mode, half step. So this is about the switching condition. 4 different condition we have. To based on two switch, we have 4 different control: 0 0 0 1 1 0 1 1, and based on that, it may be off, it may be single phase, two phase, half a step. So is it okay? Clear? Is it okay? Yes. And if nothing is done, so if so, that means 4 different conditions are there. If nothing is done, it will go to the start mode again. It will start working again. If nothing is there, I mean one of nothing is there. So after that, so that means it will go to the forcefully to the start. Jump, start. Okay. So now it's about, let us define the this 4 mode, off mode. Off fast. So how can we make the off? You know, the very simple thing. If you send 0, all the 4 bits, 4 phases 0, then it will be off. So we here only the lower 4 bit, right? So other 4 bit must be 0. Symmetrical. No, L, comma, 0, 0, H. Because you know, okay, let me draw it. This is about the port A. Motor is connected in the port A, and this uh, A, B, C, D, 4 phases. I mean, 4 bit is connected to 4 phase. So these are, I mean, this, I mean, so 0 to 7 and 7 to 4 to 7, they are not used here because 4 phase, it is connected to the motor. Okay. So we said last class that it must be symmetrical. This higher 4 bit, it must be same as lower 4 bit, because you know I mean otherwise actually we will not get the right operation. Okay, so anyway, so 00H, for example, for off mode, it is very simple. Send 00H. That means all the phases become 0 0 0. Here 0, and higher 4 bit, it must be symmetrical like lower 4 bit. So lower 4 bit is all 0, so higher 4 bit also all 0. And then so send it to the port A, because port A is connected to the motor. So out port A, comma L. So that means it is off. Then what actually? So motor is off. Then jump, start again. So it must go to the again and again. It should check it. What are the switch condition there? Jump, start. Okay, this is about off. Off is done. So now it's about the second operation, single phase. So we define it SP. SP. Okay, so how can we make it single phase mode? It is already we said for single phase mode. If you look at here, so one phase on. So that means this one is just A phase is 1, all are 0, all are 0. So it's like that. And then we have to make the left rotation 1 bit, and then B will be 1, all are 0. But you know that this is bit, this 4 higher 4 bit, they are not used, but they should be symmetrical like the lower 4 bit. So so that means in a hexadecimal it is 11H. So we have to send 11H. So move L, comma 11H. And also, you know, we have to make 8-bit 4-bit rotation, because it is complete revolution, or complete rotation. 360-degree rotation is done by four steps. I mean 4 times we have to make the I mean within a 4 step, it completes it completes a full one revolution, one rotation. Okay, so so move x, comma 4, and then out L, comma sorry, out port A, comma AL, then rotate ROL, rotation left L comma 1, okay, and then loop, okay, loop here, loop, for example, L is here. So that means it will come to the loop. Yeah, this one is here. So it will so four times it will continue. Yeah, it will make the rotation, because yeah, left rotation of this one. So what will happen in the 1-bit rotation? Then that means this one is 1, and this one will be 0, this one will be 0, and everything will be same here, 0, 1, 0 and 0, and this 0 come out here. So like now B phase is on, then 1 bit, all other bits are 0. This is 0, all other bits are 0. So B phase is on. Look at the ABCD. So then what will happen? 1 bit left rotation, it will make C phase on only. So for how many times? 4 times. That's why we have a counter. So it's actually make the loop 4 times, and then jump. Once it is done, one complete rotation is done, then jump, start. It will go to the start mode. I mean, it will go to the starting to check the thing, switch condition again and again. Okay, and then what will happen for, so this is for SP mode, and now for yeah, single phase mode. So 2 phase is TP. We write it TP. So what is in 2 phase mode? We have to send what? We have to set 1 1. Okay, I mean A and B together. So if A and okay, A and B together, so that means it is 1 and it is 1. Is A and B together, and C and D 0. So the same thing symmetrical, higher 4 bit also. So that means 3 3H. We have to send 3 3H. Move L comma 3 3H. And also counter should be 4. Move CX comma 4, and then out port A comma AL, and then rotation left AL comma 1, and then loop, and so it will come up here. So and then how many times? 4 times. Then jump, start, start. It will come up to the start. I mean, to check the switch condition again and again. Is it in the, if it is the same situation, it will work 2 phase mode again. If it is different mode, so it will go for that one. Okay, so until now it is okay, clear, because it is already we discussed in the last class, and again we repeat it again. Is it okay, right? Yes. So first part is initialization. Okay, so this is initialization, and then this is about reading the switch condition. This is about reading the switch condition. This too, and this yeah, here. This is about the switch condition. Okay, and now it is about the off mode. This is for off mode. We have to send 0 0. Okay, for single phase mode, we have to send 1 1. And then we have to make left rotation 1 bit, and then again we have to send it to the motor again and again. And it is for 2 phase mode. So only the tricky part here. So this is very easy, but only half a step mode. So this is the tricky part. We will let us see how can we make the half a step mode. And half a step mode, you can remember. So we have to make it single phase first, and then 2 phase, again single phase, 2 phase, it's so on. So that means first of all it will be A phase only, then A and B, then B phase only, then C and D, and then D, it's so on. Okay. So how can we? So what will be for half a step mode? Half a step we write it H as SS. Okay. Mob C mob A comma half for half a step. Half a step. First of all, it is single phase. So 1 1 H. Okay. 1 1 H. Then and it is also it must yeah mob px 4 okay out port A comma AL. So that means it is now in one phase mode, okay, single phase mode. So then we have to yeah. So this mob AL. So we send 2 to H in another register. We load 2 to H in another register, and then we add them together. Okay. So then it will be 3 3H. Add AL comma BL. Okay. And then add AL goes. So it becomes now AL has 33 3H. Out out port A comma AL. So it becomes 3 3H. But what about this 1 1? So 1 1 is we must preserve it. Otherwise, actually, because this is in A, this was in AL. Now AL is now 3 3H. This 1 1 actually it is lost now. Okay. So we have to use another register here to save it. Okay. So maybe we can use like mod H comma AL. So that means a 1 1 is also saved in AH. Okay, because all we are using AL again and again. So if 1 1 H is not there, it will be lost. It will be so now we have to make the 1 bit rotation of AL and 1 bit rotation of AH and 1 bit rotation of BL. So rotation left AH comma 1 and rotation left EL not yeah BL, okay, BL comma 1. Okay, so then now move, okay, let me write it here, move AL comma AH. So AH is now loaded in AL again, and then we'll loop it. Loop. Okay, so loop it is P. So P is here. Okay, now look at here. One thing is actually we can see that this BL we should write it out of the loop because it is fixed. This fix we will keep it right. Okay, let me check. Now it is okay. Look, okay, and then it will continue for 4 times, and then it will complete a one revolution, and then jump. Jump, start. So then end. E and T. So this is the ending. Okay, now look at here. I'm explaining it. First of all, we say we make AL equal 1 1H because 1 1H we need it for single phase excited mode, and for two phase excited mode we need 3 3H. So 3 3 actually we get from 1 1 plus 2 2. Okay, so we actually use move BL comma 2 2H. Okay, and then counter value is 4 because loop will be 4 times, and this AL value 1 1H we will save it also AH because AL we will use it again and again. So this 1 1 it doesn't, I mean it is not, so that it is not lost. Okay, AH, and out port A comma AL, that means it is in one phase mode. Okay, now add AL comma BL. So AL is 1 1 and BL is 2 2. That means 3 3H. So now send it out port A comma L. Now that means it is 3 3H. Okay, so 3 3H, that means it is two phase mode. And now rotation of AH comma 1, because AH has 1 1, we keep it in 1 1 in AH. You can see. So make it 1 bit rotation, and also BL comma rotation left BL comma 1. This is also 1 bit rotation, and then move AL comma AH. So AH is sent to the AL, and AH is sent to the N, and loop a P. So it will then it will be sent to the stepper motor again. That means yeah. So single phase, it is again B phase. I mean single phase mode, and then add AL comma BL. So AL, yeah. So everything, look at here. So first of all, it will be 0 0 0 1 and 0 0 0 1. So this is 1 1. Okay, and what is 2 2? 0 0 1 0 0 0 1 0. So it is 2 2. Okay, so if you add them together, it will be 0 0 1 1 0 0 1 1. So 3 3H. So that means 2 2 is not, this is not for two phase excited mode. I mean we use it another, I mean we use it for making the things, making the logic easy for us. Okay, so now look at here. If we make so this is it. So first one is this 1 1 in AH. This is, we put it in AH, and this is we put in BL. Okay, so now one bit rotation of AH, it becomes like 0 0 1 0 0 0 1 0. This is for one bit left rotation of AH. What about the one bit left rotation of BL? It becomes 0 1 0 0 0 1 0 0. Now if you add them together, it will be two phase again. Okay, 0 1 1 0 0 1 1 0. So that means it actually makes the after adding, after addition it becomes like two phase mode. So for one phase mode, two phase mode, one phase mode, two phase. This is the way we will get the 4 times. If one phase and two phase mode, if they 4 times, they will repeat the things, then it will complete a one revolution or one rotation, complete a one rotation. Is it clear? This is okay? Is that okay? This logic is okay, clear? So this is about about control the operation of a stepper motor. So this okay. So and until here. So if you have if it is not clear, then ask me again.
Doctor.
Yes.
I have a question.
Yes.
In two-phase, move AL 33. 33. Why we don't put 22?
22 means look 22 means 0010 and 0010. Here is actually one phase. Actually, it is also and one is just for one phase. So how can it be two phase? Two phase means at a time two phase should be on. Like you can see, you can remember if you can see it. So 3 means 0011. So that means A and B two phase on, C and D off. Then we yeah, and higher 4-bit also symmetrical, I said, like the lower 4-bit. So that means 3 3H. Now if you make the 1-bit left rotation, it will become 0 here, 1 here, 1 here, 0 here, and here also same thing happened. So that means now it is B and C on only, B phase and C phase. Then a 1-bit left rotation, it will be C phase and D phase, and 1-bit left rotation, D phase and A phase. Okay, but if you send two means two means one phase on. So so this is I said in the last class also. That means for we can see it easily also, that for two phase we need 3 3H, and for one phase we need 1 1H. Okay, so if you do not have any questions, so we will finish this chapter here. So next class, we have actually 1 week left. Next week. So Sunday actually we'll start a one chapter, and shortly we'll finish it also. And that's all for this syllabus. And syllabus for final we'll discuss in the next week. Next week we'll discuss, and we'll discuss in the next class. And this is about all. So here, what are the things we discussed so far? Yeah, next class. Next week, inshallah, we'll discuss all the things next week. Okay, so so then, I can erase it, right? Erase the things. So in a stepper, in a input-output interfacing, what are the things we learned so far? It is, so one is LED and switch. This is a simple one, as like the lab. LED and switch interfacing, and we also learn about DC motor operation control using the switch. Then we just finish in switch. Okay, and then traffic light system. I mean, it is. Yeah, it is. It's a bit okay. Let me see. Let me see. And then 7. Okay. So is there any other thing missing? Yeah. So this is about yeah. So this is about input-output interfacing, 8255 IC and input-output interfacing. So this chapter basically we discuss 4 examples. I mean 4 different types of example. Okay. So 4 different types of example learned so far. So yeah, this is about for this chapter, and I think you can. I mean, we can make a quiz based on it. Okay. So because quiz now 4 quizzes are taken, one more quiz we need. So when actually the quiz, when is the suitable time for you? Next Tuesday. Okay, so next Tuesday, inshallah, next Tuesday, you will have a quiz. Okay, next Tuesday, and yeah, this is next Tuesday. Okay, so quiz 5 will be on next Tuesday. So based on this chapter, okay. So this is 8255. Quiz 5 will be on next Tuesday, based on 8255 IC and input output interface. Okay, based on the yeah, these things. So already you get some basic thing on the measure 2. So yeah, kind of like that. So measure 2, if you, I mean, yeah, you need more preparation for final. So this is about, and lab final. Okay, so it's about lab final. Lab final, it will be based on experiment number 4, 5, 7, and 9. Okay, so yeah, this is about the lab final exam. So next week on lab time. Yeah, so it is physical, not online. You know that, yeah, the online, yeah, it is already, yeah, university decision that lab final exam will be on the last week, and next week is the last week, and it will be physical like the final exam also. So experiment number, according to the manual, experiment number 4, experiment number 5, 4 is like a LED and switch, and 5 is like a traffic light system, and then 7 is DC motor operation control, like this one, and then 9 is like the one that we said in the last class yesterday. Yeah, the brightness control. Yeah, so you have to understand. So if you do not understand, just think, if you memorize the thing, there is no benefit of it. So you have to understand it. Otherwise, actually, how can I check if I do not, I mean, do not change anything? So don't memorize anything without understanding. So experiment number 4, 5. So just only 4 experiment. Okay, 4, 5, 7, and 9. According to the manual, because only these 4, after the mid lab we I mean, yeah, we did this 4 experiment, actually, this 4 experiment, that's why nothing more than that. All right, so lab manual, and yeah, final exam schedule. Actually, I don't have anything final, so that's why it is not, I should share with you. I have because as an exam committee member, I got one copy, a tentative one. So you will be confused with it. So don't. I think it's better wait for one. I mean, 1 or 2 days. You will get the final one. I got one just for discussion, as I am a member of a exam committee, but that is not final, actually. So if I say the things, you will be confused. So it's better wait for a few days, and you will get the final. Okay, so it is like that. Any question do you have? And next week we will discuss about the final exam. So lab final, it will be okay. So lab final will be Final. Let us change the color. Exam. Monday. Monday is Monday is 12 April 12. Till 12. So lab final exam will be on coming Monday, April 12 at 2 p.m. Okay. So any question do you have here? Okay, so that's all for today.